Hey guys, it's me, Miss Mills, and welcome to Mrs. Mills' Math Time. The whole point of this video is to help you out with identifying linear and nonlinear functions notes. This video goes along with the notes, and watch it for some explanations and fun stuff like that. Guys, I'm really hungry, so I'm going to make this video as quick as possible. So if y'all remember from last week, we talked about functions and what it meant for something to be a function. And if you remember, for something to be a function, it meant that each input could only have one output, or each x value could only have one y value, and x value couldn't have two different y values. So yeah, again, a function had to have only one input for one output. And if you don't understand, I would recommend watching the video from last week explaining functions. And if a graph was going to be a function, the only thing it had to pass was the vertical line test. And if y'all remember the vertical line test, that's where you put lines on the graph to see if it only touched the graph one time at any given time. If the vertical line touched the graph more than that one single time, it was not a function. Again, that is from last week, so if you have questions about functions, I would recommend watching that video first. But today we're talking about linear and nonlinear functions. Now, they're still functions, it's just a subcategory of functions, so the requirements are a little bit more strict, and that's what we're going to talk about today. So, for a graph to be a function, all it has to be is a straight line, okay? So for a graph to be a function, it only has to be a straight line. If it's not a straight line, it's not going to be a linear function, okay? Also, remember, if it is a straight line and it goes to the origin, it's also proportional. So guys, don't forget stuff that we talked about a couple of weeks ago when we talked about if something was proportional or not. Try not to confuse them either, so make sure that you know the difference between proportional functions and today linear functions. So don't mix those all together. Make sure you have them separated. But yeah, a linear function has to be a straight line, and that's it. Now for an equation to be linear, it has to be written in the form of y equals mx plus b. That's the only way for it to be linear. So we can't have anything squared or nothing like that. We have y equals mx plus b, where m is the slope and b is the y-intercept. Now, this y-intercept can be 0, so that means it can just be y equals mx, because you don't have to put plus 0 on anything. That can be taken off. Also, the slope can still be 0 as well, leaving you with just y equals the y-intercept, because it still makes it a straight line. So just be careful with that. It has to look like y equals mx plus b, but the slope can sometimes be 0 and the y-intercept can sometimes be 0. So just be on the lookout for that and be careful. And the very last thing is, for a table to be linear, it has to show a constant rate of change throughout the entire table. So what that means is you're going to pick out some ratios, and remember, ratios are always y over x, not x over y. It's always y over x. You're going to pick a few ratios and you're going to reduce them, and when you reduce them, if they're the same number, then it is a function. If they're not the same number, then it is not a function. So let's look at some examples of what wouldn't be a linear function and what would be a linear function. And whenever you're finished with these notes, go ahead and do the IXL for this week, which is an excellent question. I believe it is Z17, which is identifying linear and nonlinear functions, graphs, and equations to 90%. But let's finish this up then. So here's an example of something that's not a function. Here's the equation. The equation is y equals x squared plus 1. Again, because the x is squared, it does not fit the requirement of being in y equals mx plus b. Therefore, that's why it's not a function. But here's the equation as a table. Again, if we pick two ratios, just like we did when stuff was proportional or non-proportional, I picked two ratios, 2 over 1, and I picked 5 over 2. When reduced, those ratios are not the same number. Because of that, that's not a linear table. And then here's the equation as a graph. It's not linear because it's not a straight line. It's curved, just like this. So that's why this equation is not linear. And here's the example of it as a table and here as a graph. So you need to be able to look at a graph and figure out, is it linear? Look at a table, figure out if it's linear, and look at an equation and say, is that linear? So make sure you know the difference between all of those. And let's look at an example of something that is a linear function. So here's the equation, y equals 1/2 x. Now, the reason we don't have a plus b here is because the b is 0. That means that the line crosses the y-axis at 0. Because of that, we don't have that plus b there. But this equation does still fill the requirement of y equals mx plus b. It's just, again, the b is 0. Okay? So that's why this is a function. Now here is it as a table. Again, we pick ratios, and I put all the ratios in here except 0 over 0 because, again, you don't pick the ratio that has 0 in it. This one is negative 2 over 4. That is a function. Or sorry, negative 2 over negative 4. When reduced, that's a ratio of 1/2. Same thing here. Here is a ratio of negative 1 over negative 2. Again, when you have a negative in the numerator and the denominator at the same time, it cancels out, making that a positive ratio. Same thing here. 1/2 is 1/2. And then 2 over 4, again, is when reduced is 1/2. So let me fix these ratios real quick because I actually did them wrong. I made them x over y, which is not what your ratio is supposed to look like. It's supposed to be y over x. So let me fix those real quick. Not really sure why I did that. Maybe I just wasn't really paying much attention, but I will make sure that this is fixed for you. And then we have 2 over 4. So again, let me write these ratios out for you. And then we have 2 over 4. So again, I'm writing out all these ratios for you. Negative 2 over negative 4. Again, when you have a negative in the numerator and the denominator at the same time, that cancels out. 2 over 4 can be reduced to 1/2. All right. The second ratio is negative 1 over negative 2. Again, a negative in the numerator and the denominator cancels out, giving us a positive 1/2. This one is as reduced as it can be. It's 1/2. And then 2 over 4 can be reduced to 1/2. So I picked all the ratios, and when reduced, every single one of them is the same number. So that's why the table is a function. Again, we know it's a function because the equation goes along with the table, and we know the equation is a function. I just wanted to show you how you would figure out if you just had a table, if it was a linear function or not. Okay? And then the very last one, we have the graph that goes along with this equation. It is a linear function, and the reason is because it's a straight line, and that's just the way it is. That's all you have to look for there. So guys, that's really all it is just knowing what you're looking for when you're figuring out if it's a linear function or not, and then being able to practice it. If you have any questions, remember, don't hesitate to contact me. I'm always happy to help. I'll see y'all later, and have a great day. Bye.